Okay, isomers. There are lots of different kinds of isomers in organic chemistry, and we have to get straight in our head the different names of all of them. So we can have constitutional isomers with alkenes. And the alkenes usually have more possible isomers than an alkane with the same number of carbons. Because not only can we connect the carbons differently, but we can move the double bond around. So let's remember that a constitutional isomer has the same molecular formula, but the structural formulas are different. Positional isomers have the same carbon chain or the same carbon backbone. The difference is that the functional group is in a different place. So the double bond for the alkenes is in a different place. The carbons are all attached the same way, only the double bond is moved. That's a positional isomer. The functional group is in a different position. Alkanes can't have positional isomers because they don't have a functional group that could be in a different place. And then we have skeletal isomers where the skeleton is different. Positional isomers, the double bond has a different position. A skeletal isomer is going to have a different carbon chain arrangement. So let's look at some of these guys here. So here we have 4 carbon alkanes. There's butane, and then we can make a skeletal isomer or a constitutional isomer by connecting the carbons in a different way. That's all we can do. There's only 2 isomers possible for that. When we look at the 4 carbon alkenes, there's 3 different isomers. We can have this connection, this branch chain, like the methylpropane over here, but then we have 2 different straight chain arrangements. These 2 are positional isomers. The difference is that here the double bond is between carbons 1 and 2, and here it's between carbons 2 and 3. The carbons are still connected in the same way. You see the difference? These are isomers of each other. They all have the same number of carbons, same number of hydrogens, the same chemical formula. But they're different kinds of isomers. These 2 are considered positional isomers, and this is a constitutional or a skeletal isomer with these guys because it's connected differently. As the number of carbons increases, then things get a little more complicated. You get more isomers. Now for the alkane, you can have the straight chain. You can have it branched here where you have a tertiary carbon, and you can have it more branched where you have a quaternary carbon. These are all constitutional isomers or skeletal isomers. When we go to the 5 carbon alkene, we have 2 different straight chain positional isomers where the difference is the carbon-carbon double bond is just in a different place. The carbons are still arranged in a straight chain. And now when we look at this branch chain, there's 3 different possibilities. We can have the double bond here between this tertiary carbon and the primary carbon. We can have it here between the tertiary carbon and a secondary carbon, or we can have it over here on the end between a secondary and a primary. There is no alkene version of this because this quaternary carbon can't have a double bond. There's nowhere for a double bond to exist in this with this skeleton. Any questions? So let's draw condensed structural formulas for all the alkene constitutional isomers that have the molecular formula C4H8. And those were just on the previous slide, but we're going to do this just kind of as a learning how to think about a question like this. So 4 carbons. Well, one possibility is just 4 carbons in a row, a straight chain. C4H8. That tells us there's one double bond. So we could put the double bond on the end, and then this would be CH2, and this would be CH, and CH2, and CH3. And then we're going to double check that each of these carbons has the right number of bonds. This carbon has 2 bonds to hydrogen, 2 bonds to carbon. This one has double and a single, that's 3 bonds to carbons and a hydrogen, and these guys are fine. And we've got 3, and 2 is 5, 6, 7, 8. We've got the right number of hydrogens. So that's one possibility. We can write a positional isomer for this by moving the double bond. If we put the double bond in the middle, that's going to be different, isn't it? So 4 carbons, and put the double bond in the middle. So now we've got a CH3 over here, and that's going to be CH, and that's going to be CH and CH3. Now, if we move the double bond from the middle to the end over here, is that going to be a new isomer? No. That's going to be the same as this guy, just flipped over. Let's turn him around and it's the same thing. So those are the 2 straight chain isomers, and then we can do a branched chain. And we could put the double bond here, and we've got 2 carbons there. These guys are going to be CH3. How many carbons does this guy in the middle have? How many hydrogens? Does he get any hydrogens? No, because he's got 1, 2, 3, 4 bonds to carbons. So, is there a positional isomer for that guy? Can we move the double bond to a different place and have it be a different molecule? What if we put the double bond over here? Is that going to be different? No. It's just going to be turned around. So there's 3 different isomers for the C4H8s. Any questions?